Alright, so here we are with the next lesson, and we're going to start to get into actual chemistry stuff. And what we're going to look at is, well, before we do that, let's just go through what kind of similar to what we talked about before. How do we measure matter? And this always comes up, the difference between mass and weight. Well, in chemistry, we never use weight, we always use mass. And the reason for that is that the weight of an object can vary depending on gravity, the strength of gravity. Most, or if not all of you, have taken earth science, so you know, of course, that the earth is not a perfect sphere. It's called an oblate spheroid. So it's like taking a basketball and stepping on it a little bit. You're going to flatten out the tops and the bottom, and the sides are going to expand. So technically, if you're at the north or south pole, you're a little bit closer to the center of the earth, which means gravity is a little bit stronger, so you're going to weigh slightly more at the poles than you would at the equator. So scientists cannot use something that varies like that. Mass does not vary, it's not dependent upon gravity, so we only use mass of an object. And that's what it's talking about, as you can see right here. How do we measure the volume? The volume is the amount of space an object takes up. So, for example, if I wanted to measure the volume of a liquid, I'm going to use a graduated cylinder, like we talked about at the beginning of this unit. If I wanted to determine the volume of a regular solid, now a regular solid would be something that's either a rectangle or a square, I'd use the formula length times width times height. If I wanted to measure the volume of an irregular solid, like for example a rock, I cannot use length times width times height because it's not a regularly shaped object. It's irregular. So I'd have to use the displacement method. If you're not familiar with that, you should I think you probably already know how to do that. Basically, you use a graduated cylinder and you put in, let's say, 50 milliliters of water in the graduated cylinder. You drop your rock in, and let's say that the volume of the water goes from the 50 to 75. That means that the volume of your rock is the difference between those two, 25 milliliters. The rock displaces an amount of water equal to its volume, and we'll get a chance to do this in lab. Let's look at density. Density is the amount of mass in a given space. It's basically the ratio of the mass to the volume. The formula is on reference table T. It's mass divided by volume. You take a look at these two boxes here. These are kind of particle diagrams, box A and B. Notice how there's a lot more particles and they're closer together. So the question is, which box has a higher density? Explain your answer. Well, box A would have a higher density because it has a larger ratio of mass to volume. You notice how the boxes are the same volume? But look at how many more particles you have here. So this box is going to have higher density than this box. Let's look at a few density problems. Again, remember, the density of water is actually 1 gram per milliliter or 1 gram per cubic centimeter. A milliliter of water and a cubic centimeter of water are equal. That's the only substance that is true for. If you take a look at, and again, I'm not going to spend a lot of time on density because they don't ask a lot about density on the Regents exam, so there's really no need for us to spend a lot of time. So here's just going to do a couple of questions. Density equals mass divided by volume. Now here's a couple of numbers. 60 grams. How do I know if that's mass, volume, or density? Well, grams are going to be mass, so that goes on the top. So you have density equals 60 grams. And remember up here, this is cubic centimeters. That's going to be volume. So either milliliters or cubic centimeters are volume. So that goes here. 2 cubic centimeters. And when you divide that, 60 grams divided by 2 cubic centimeters, you are going to get 30 grams per cubic centimeter. Notice how the units are different. So when you divide them, you include both of them. So the units for density are grams per cubic centimeter. So it's 30 grams per cubic centimeter. That's a pretty dense object, right? The higher the density, the more dense it is. All right, number 2. It says if you have a gold brick that is 2 centimeters by 3 centimeters by 4 centimeters and has a mass of 48 grams, what is its density? Well, it's a brick, which is a rectangular shape. So you're going to multiply length times width times height. So you have the density is 48.0 grams. And I'm going to multiply these together. 2 times 3 is 6. 6 times 4 is 24 cubic centimeters. Now, where do we get cubic centimeters? Well, look at, you're multiplying centimeters 3 times. So this is going to come out to, the density is going to come out to 48 divided by 2 is going to be 2.0 grams per cubic centimeter. Now, why did I leave it as 2.0? Well, when you're dividing, remember, it's the fewest number of significant figures, right? That has 3 significant, this has 2, so your final answer can only have 2 significant figures. Okay, so let's go back down here. All right, let's do 3 and 4. All right, so now this is going to be a little different. Now this one is giving you the density. That's the density. And they give you the mass. So they're asking you for the volume. So you have 0.6 grams per cubic centimeter equals 120 grams. And we don't know the volume. So that's going to be X. Now, it's basically just a little bit of algebra. I'm going to cross multiply. So what I'm going to do is I'm going to put this over 1. And I'm going to cross multiply. So I'm going to shorten it. 0.6x equals 120. I want to get x by itself, so I divide both sides by 0.6. That cancels out. And now I'm going to simply divide 120 by 0.6. So let me get to my calculator. 120 divided by 0.6 equals, it looks like to me that the density is approximately 200. I mean, the volume is approximately 200 cubic centimeters. All right. Now, number 4 is a very similar one, except in this case, you're trying to find the mass. So they give you the density is 6.0 grams per cubic centimeter. And they give you, in this case, they don't give you the mass, that's the x, but they do give you the volume. So again, you're just going to cross multiply. So I'm going to put this over 1. This is really easy because you end up multiplying just the density times the volume. So I'm going to end up multiplying 6 times 34. And I'm going to get as the mass 204. 204 grams is the mass. And if you check this out, if you put 204 at the top and divide by 34, you should get 6. Okay? And again, density is not a big part of chemistry. You talk about it more, obviously, in earth science. Oops. Okay. Let's go back to that. Okay. Number 5 is kind of a trick question. Which is heavier, a ton of feathers or a ton of bowling balls? Well, neither one is heavier. They're both a ton. It's kind of a trick question. And the last, so let's call that a